You've got two sensors recording the same experiment. They should have identical data, but one might be broken. A broken sensor drops exactly one reading, everything after it shifts left, and the last spot fills with a random value. Given both sensor arrays, figure out which one is faulty. Return 1 if sensor 1 is broken, 2 if sensor 2 is broken, or -1 if you can't tell. Here's an example. The original data is 2, 3, 4, 5, 6. Sensor 1 reads it correctly, 2, 3, 4, 5, 6. But sensor 2 drops the 4. Everything shifts left, giving 2, 3, 5, 6, and the last spot gets a random 8. So sensor 2 reads 2, 3, 5, 6, 8. The tricky part, you don't know the original data. You only see the two sensor readings side by side, and at most one sensor is broken. How do you figure out which one dropped a value just by comparing the two arrays? Here's the key insight. If a sensor dropped a value, everything after that point shifts left by 1. So the two arrays will match perfectly up to the drop point. Then one array looks like a shifted version of the other. The approach has two phases. First, scan both arrays together until you find where they first disagree. That's the potential drop point. Second, from that point, check which sensor could be the shifted one using an elimination process. Let me walk through the example. Sensor 1 is 2, 3, 4, 5, 6. Sensor 2 is 2, 3, 5, 6, 8. Phase 1. Find the first difference. Index 0. Sensor 1 has 2, sensor 2 has 2. They match. Index 1. Sensor 1 has 3, sensor 2 has 3. Match again. Index 2. Sensor 1 has 4, sensor 2 has 5. They disagree. We stop here at index 2. Phase 2. Determine which sensor is faulty. We check two things at each position. First, could sensor 2 be the shifted one? If sensor 2 dropped a value, then sensor 2's current value should match sensor 1's next value. Sensor 2 at index 2 is 5. Sensor 1 at index 3 is 5. They match, so sensor 2 being defective is still possible. Second, could sensor 1 be the shifted one? If sensor 1 dropped a value, then sensor 1's current value should match sensor 2's next value. Sensor 1 at index 2 is 4. Sensor 2 at index 3 is 6. 4 doesn't equal 6. That eliminates sensor 1 from being the shifted array. Since sensor 1 can't be the shifted version, sensor 2 must be the defective one. Return 2. Why does this work? We're eliminating hypotheses. At each step after the first mismatch, we check whether each sensor's shift pattern is consistent. The moment a pattern breaks, we know that sensor can't be the one that shifted, so the other one must be faulty. If both patterns stay consistent all the way through, we can't tell which sensor dropped the value, so we return -1. Time complexity is O of n. We scan through the array at most twice, once to find the mismatch, once to check the shift patterns. Space complexity is O of 1. We only use a single index variable, no extra arrays needed. Found this useful? Master key interview patterns at AlgoMonster and land your dream job.